Hey, everybody. Welcome back to the Doctors In podcast. I'm your host, Dr. Nadia Saba, president and founder of Dr. Greenhouse. This is our special series, What Plants Crave, where I'm talking to growers about the plants they grow in greenhouses and indoor farms, and in this case, in the field. My guest today is Emma Menden, who recently graduated from the University of Arizona Biosystems Engineering graduate program under Dr. Barry Pryor. Just a few weeks ago, she defended her master's research, which looked at different lettuce cultivars and their potential resistance to Fusarium wilt, which is one of the most devastating lettuce diseases worldwide. For her research, she looked at nearly 60 different cultivars from romaine to iceberg in an effort to find individuals that are not so susceptible to the Fusarium fungus. Next for her after graduating is she's going to go work as an apprentice grower at Bright Farms, which is a multi-state greenhouse producer of hydroponic lettuces. Today, we are going to focus on her research, what she learned, and what's next for her in the world of controlled environment agriculture. Emma, welcome to the podcast. It's so great to have you on the show with me.
All right, thank you, Nadia. I'm very excited to be here. I know a couple of years ago you came and interviewed some other students, and I was a little bit jealous, so I'm really
Ah.
happy to be here.
Well, now's your chance. So let's start with the why. Why did you choose to study Fusarium wilt in lettuce crops?
So, Fusarium wilt is one of the most important lettuce pathogens of this century. It was first identified in Japan in the 1960s, but since then it's spread throughout the world. And in the US, it's predominantly found in California and Arizona, which are the most important lettuce producing states in the US. I think we produce about 95% of the lettuce that's consumed here. So it's really of interest. You know, University of Arizona is an ag school. So we'd really like to help the growers out and try to prevent the devastation that this disease can cause.
So, what is it? What does it look like? How does it affect the plants? What are the symptoms?
So Fusarium wilt disease is a fungal plant pathogen, and it's caused by a fungus called Fusarium oxysporum. The type that's of interest here is Fusarium oxysporum forma specialis lactucae. And forma specialis is an informal taxonomic classification for host-specific pathogens. So Fusarium can affect a large variety of crops like beans, tomatoes, peppers, bananas, palm, yams, all kinds of things. But what we're really looking at is lettuce. The typical symptoms of Fusarium, what you'll see first is wilting of the leaves, and then that will progress to chlorosis or yellowing of the leaves, and then you'll start to see necrosis of entire leaves or just necrotic lesions, and oftentimes it does progress to plant death. The best way to identify Fusarium actually, though, is looking at root cores. So this pathogen colonizes the vasculature of the plant. So typically it's soil-borne and it will colonize the roots and basically just obstruct flow of water and nutrients. So if you were to cut open a root core of an infected plant, you would see lots of clogging in the vasculature, and it would also look very discolored, either brown or reddish.
Is it easy to mistake Fusarium wilt for something else, like a nutrient deficiency or some other disease?
Yeah, certainly. It's very easy if you're only looking at foliar symptoms, lots of different diseases or nutrient deficiencies or something like saline toxicity has very similar symptoms to Fusarium. So that's why what I recommend to growers is to look at those root cores because that's a pretty novel symptom of Fusarium.
But then you have to take out the roots, right? So it's sort of a destructive way of identifying the pathogen, right? Like if you were in a field, would you be taking samples from various, plant positions within the field to look at their roots?
Yeah, absolutely. That's the procedure that we commonly follow. For the experiments that I was running, actually, we were using Fusarium isolates from fields in Yuma, Arizona. So a couple years ago, we had researchers go out there and pull infected plants from different locations of different fields, and we categorized all of those strains um, to look at. And then prior to my research beginning, another trial was run with like 60 different Fusarium isolates against 4 different lettuce cultivars. So that's how we were able to narrow down for my experiment the 3 FOL isolates that we used. And actually, sorry, I should have said shorthand for Fusarium oxysporum forma specialis lactucae is FOL. So that will be a little bit easier. It's less of a mouthful.
um, there are 60 different species or subspecies of Fusarium.
So there's really thousands or hundreds of thousands. We collected several hundred from just the Yuma, Arizona region. But if you were to collect samples from all along the coast of California, you would have thousands of different ones. And then if you were to go to like Italy or Japan or any other country that has it, they would all have their own independent isolates. And really, it's hard to differentiate these isolates. You can't really do it genetically. The only way to identify the different isolates is through this type of pathogenicity testing, like what we ran in this experiment. So we were testing 3 different isolates of Fusarium, and with those, we saw different reactions between or within one lettuce cultivar. So one of the isolates that we selected was very highly pathogenic, and then we had one that was kind of middle pathogenicity, and then one that was much weaker.
So not all Fusarium is the same when it comes to its, I don't know, destruction or the symptoms that it presents in these field crops or in lettuce crops.
Yeah, absolutely. And there's actually also a huge variety of non-pathogenic FOL strains too within all the different Forma specialis, but also specifically in the ones that affect lettuce. So you may have a field that's infected and you don't even know, and you don't, maybe you'll never see a problem, or maybe one day you'll switch cultivars and you'll have a serious problem. Something else that's interesting about this fungus is that some strains are plant endophytes, and they can colonize the root vasculature, and they may even protect the plants or form some sort of basis for disease suppression. And that's something that we actually have ongoing research in our lab where we're looking at treating our plants with high salinity levels to see if FOL may confer some kind of resistance to extremely saline conditions. Like the fields in Yuma are considered to be fairly saline. So we're kind of looking at other methods of either prevention of this disease or whether in some cases it can actually be beneficial.
Wait, so are you saying that you could have one Fusarium species that could protect the lettuce crop from the destructive Fusarium species?
I actually am not sure if it can confer any resistance to other strains of Fusarium, but certainly other plant pathogens, it may provide some resistance.
Okay. When I was, what was I? I guess I was in between grad studies, between my master's and PhD. I worked on a project at UC Davis studying Eutypa dieback disease in grape vineyards. And we were looking at Fusarium as a biological control agent against Eutypa lata. So, Yeah. When we talk about Fusarium as a pathogen, my experience has actually been Fusarium as a control agent against another pathogen. So that's why I thought it was kind of interesting that you brought that up here, is that, there are maybe some beneficial species of Fusarium. They're not all bad. Some might actually be good or confer some benefits to the plant.
Yeah, yeah, absolutely. I actually didn't know that you did some Fusarium research, so that's very cool.
I did, long ago. So you mentioned also that Fusarium can affect other crops other than lettuce. Is it mostly leafy green type of crops, or could it be also fruiting, flowering crops?
Yeah, it can affect there's a huge variety. So absolutely fruiting flowering crops. So actually one of the most well-known examples of Fusarium oxysporum is Forma specialis cubensis, which affects bananas. And so if you've ever wondered why banana candy tastes different than the bananas that you buy at the store, that's actually because Fusarium was responsible for the functional extinction of the Gros Michel banana in the 1950s.
Oh.
And so then we had to move on. I don't remember the name of the banana that we use now, but um,
Cavendish?
Cavendish, that's correct. Yeah. So, and now the Cavendish banana is starting to see some issues with Fusarium. So that's definitely
Oh.
an important area of research to make sure that we don't have to switch to another new banana.
Wow, that's interesting. And bananas are cloned plants, right? So if
Yes.
if one plant becomes susceptible to it, chances are all of its sisters are going to become susceptible to it.
Yeah, absolutely. When you're relying on one variety of a specific crop, you certainly have more danger of some sort of pathogen like this causing huge issues. With lettuce, we're lucky that there's thousands of lettuce varieties. So even if you have one variety that is very susceptible to Fusarium, you have the option to select a different variety that's resistant.
So that's a perfect segue to talk about the research you did, because wow, 57, I think, different lettuce cultivars that you studied across what, three or four different species of Fusarium. That's a really big Punnett square. Um, and so, I'm curious about the various lettuces that you studied, why you chose them, why so many, and why looking at cultivars is maybe, the solution versus, against Fusarium, as opposed to fumigations or other preventative measures.
Yeah, yeah, absolutely. So we actually looked at 56 lettuce cultivars, 32 crisp head varieties, 15 romaine, and then a couple other green and red leaf and butterhead. But really, we were mostly focused on crisp head because that is one that's very popular commercially, but also very susceptible to FOL. And then romaine, also very popular, but much less susceptible to FOL. Actually, most of the modern romaine varieties are resistant. So the way that we selected these cultivars, we ordered them from several different manufacturers, Cicada, Syngenta, Goin Seeds. And so all of these cultivars that we selected are intended for cultivation in Arizona and California. So they're kind of specialized to these regions. And that, like I said, the FOL strains that we're focused on are from Yuma, Arizona. And really, we wanted to test over 100. So just with time and labor constraints, we got to 56 trials that looked really nice at the end. So we just wanted to do as many as we could so we could recommend these cultivars to growers in these regions as varieties that may be resistant. And in the end, we found 4 crisphead varieties that were totally resistant to the pathogen. But yeah, we did test three different FOL strains, and so we can really only confirm that these cultivars are resistant to these three strains.
Ah,
But real that does make it likely that they will be resistant to other strains in the area. One of the biggest problems for researchers and for growers is that these strains mutate. They can also conduct horizontal chromosome transfer. So really, every minute, these strains are changing. The strains that are found in California and Arizona have been identified to be from the same clonal lineage as those in Japan. So they likely transferred from Japan, most likely on infected seeds. But now they're kind of becoming its own grouping of strains. There are four different races of FOL. The most recently discovered one is race 4, and that one is found in Europe, and it's actually adapted to colder climates.
mm. So you discovered, you said three cultivars or crispy cultivars were resistant to Fusarium?
Yeah, four that we
Four.
found that were resistant.
Four total, or just four of the crispy varietal?
So four of the crisp head variety, 4 out of the 32. For the romaine, 15 out of 16 were resistant. So really the romaine is doing very well. We did have one romaine cultivar that was susceptible, which was really interesting. And then another interesting symptom of FOL that's probably the hardest to diagnose is stunting. So occasionally your plants will show no typical disease symptoms, but they'll just be much smaller than what you expected. So we did see that with one of the romaine cultivars as well as one of the butterhead cultivars. And that's a really important symptom because it's something that farmers cannot easily recognize as even any type of disease. They could be thinking, oh, I need to fertilize more. Oh, I didn't irrigate enough, that kind of thing.
Interesting. So what's special about romaine?
I'm actually not sure why romaine displays this type of resistance. Researchers and engineers are always working on adapting new species to create the best possible crops, the best possible yields. Resistance to FOL can either be a dominant or recessive trait, just totally dependent on the cultivar. And if we had run this trial 20 years ago, I think most of our romaine varieties would have also been susceptible. But I really wanted to look at the lineage of the lettuce cultivars that we were using because I actually had one that was a second iteration, or sorry, the third iteration of another variety we were looking at. And the first iteration of that variety was resistant, and the third iteration was not resistant. But it was kind of out of the purview of my research and my expertise to look at those types of lineages. But that's very interesting research for the future.
I don't understand. What does that mean? The first, second, or third lineage? Like you, I don't, what does that mean?
So oftentimes seed producers, they'll produce one seed, it'll work really well, but either farmers will have complaints or they'll keep breeding to create a new variety using ancestors from that original variety. So actually the one that I'm talking about is called Regency. And so we had Regency and then we had Regency 3.0 produced by the same company. I don't remember which one. And so the first iteration was resistant and the third
That
one
you
was
actually
not.
purchased from the seed company.
Yes,
Okay,
exactly.
and
And
then
so
and okay.
so they must have been trying to improve it for some other beneficial factor, drought tolerance, heat tolerance, something like that, or even resistance to some other type of lettuce disease. But through their breeding of the new variety, they lost resistance to FOL.
So if they kept reproducing seed from that original seed, the second generation was more susceptible, and then the third generation was even more susceptible.
Yeah, I didn't test the second variety, but
Okay.
and I don't know if perhaps they crossbred it with other lettuce cultivars to produce something new, because I don't think that it's
Mm,
just another like a different lot number. This is a new variety.
okay. So romaine, going back to romaine and it being the least susceptible of all the sort of groups of lettuce plants that you looked at. I mean, do you think that there's something inherent in the structure of the lettuce plant? It's taller, right? It's not like that sort of tight lettuce onion structure that you would see, with an iceberg lettuce, or even a little bit with butterheads that have a tighter center. Do you think that having those longer leaves and maybe thicker leaves could be, I don't know, a deterrent from Fusarium being able to travel up the vascular tissue?
That's actually a good question. I'm not sure if the plant morphology may have some type of resistance factor, but that's definitely very interesting. Because yeah, occasionally when we would pull root cores from infected plants, we would see discoloration in the root core, but the plants looked fine.
Hmm.
So that definitely could be a reason.
And you used a greenhouse, right, to do these trials?
Yes, yeah. So we ran these trials in a greenhouse, but what was really novel about this experiment is that we're using untreated field soil. So typically, when you see these types of variety trials, really variety trials for disease resistance or even specifically resistance to Fusarium are not rare. But what they typically do is if they're using field soil, they will sterilize it first. But because we didn't do that, we're able to maintain the natural soil microbiome. And it
Mm.
also, commonly when you're working with sterilized soil, if you do have some other type of fungus or bacteria that somehow gets into your system, you can see a huge bloom of that bacteria or fungus because there's nothing there to compete with it.
Yeah. Interesting. So did you test those soil samples first to make sure that they didn't already have native fusarium in them, so that because I'm assuming you inoculated that soil, right?
Yeah, so we actually did not test the soils for Fusarium, but during our trials, we did have control plants as well in our system, and we never
Okay,
saw any symptoms from the control
got it.
plants. So there very well may be Fusarium in that soil. It could be a different form of specialis. It could be non-pathogenic. We really, it's definitely possible.
So for what greenhouse conditions were you trying to achieve? Were you trying to simulate what a lettuce grower in Yuma or Salinas would be experiencing in their fields?
Um, yeah, so we were running at about 72 to 75 degrees Fahrenheit. We definitely had higher humidity than what you would see in Western Arizona. But the reason that we wanted to run this in the greenhouse, obviously, for the controlled environment conditions, lettuce is typically a winter crop in Arizona and California. And Fusarium is much more pathogenic at higher temperatures. So one of the recommendations we actually give to farmers is earlier season planting will help prevent this type of infection in their crops.
Interesting. So I was going to ask that question about, are there certain conditions that are more conducive to uh to fusarium growth and parthenogenesis? You just mentioned Fusarium likes higher temperatures. Does it also like it drier or more humid? Does it, matter if it's windy or sunny or cloudy or rainy?
No, the other conditions aren't as important, I suppose. I think that there is some information that higher soil moisture can be beneficial to the pathogen,
Oh,
right?
sure. It's a
But really
mold.
it's
Yeah.
yeah, yeah. Really it's those higher temperatures. I know before I mentioned that transmission of the disease from Japan to the US was likely through seeds. And when seeds become infected, it's not through gametogenesis. So it's not during the production of the seeds. It's actually when the crops are harvested and the seeds touch either infected plant matter or infected soil. That was a little off topic.
No, that was fine. I mean, that's one of my questions. You mentioned earlier that the you know the theory is that Fusarium was introduced to the US from, it hitched a ride on seeds from Japan. And so how is it transmitted now? Is it just that has it still infected the seeds, and so now when we plant those seeds it's spreading, or is it now sort of inherently in the soil that has been, growing lettuce plants for generations, and it's kind of, set up its home in that soil, and it's hard to remove it once it's sort of established itself there? Or is there another way that it's getting transmitted to these plants?
No, that's exactly right, that it's really become established in the soils around these areas. So yeah, actually, lettuce production is seasonal, like I said. So they'll they'll grow lettuce in Northern California during the hotter months, and then during the coolest months of winter, it'll be done in Southern California or Arizona. And because of this seasonal nature, equipment will be used in one region and then move to another region and then
Mm,
another region. So that's how localized dispersion of this pathogen most likely
interesting.
happened in the US. So that's why also one of the recommended ways to mitigate is through intensive equipment sanitation to prevent the spread. Um, but so once it's become infested in a field, it's very difficult to get rid of. Occasionally, crop rotation can be beneficial, but it's essential to select crops that aren't like asymptomatic hosts. So something like if you were to rotate with lettuce and broccoli, you're still going to maintain that Fusarium inoculum in the soil because it's still colonizing the broccoli. You're just maybe not seeing symptoms.
Hmm.
There are some soil fumigants available. They're super expensive, they're difficult to apply, and there's a lot of restrictions on their use because it can harm surrounding ecosystems. Another popular way to mitigate this pathogen is soil solarization, where you cover the fields with plastic tarps and allow the sun to essentially superheat the soil to kind of suppress the amount of the fungus in the soil. But like I said, it's extremely hard to get rid of. So that's why in this study, what we're really advocating for is the selection of resistant lettuce cultivars to combat this disease.
How deep does the Fusarium colonize the ground? Like, is it on the surface, or is it an inch below or 10 inches below? Do we know?
I'm actually not sure about that one. I can't imagine that it goes too deep into the soil, but probably the top couple inches.
Okay. I was just thinking with solarization that, it you can only really penetrate so deep into the soil. So if the Fusarium is below, that layer, or that inoculation depth, then yeah, it might not have as big an
Mhm.
effect or improvement as we'd like it to. It's interesting that you said that broccoli can be asymptomatic? Is it that the broccoli stalk is asymptomatic, but the leaves might express, show symptoms? But since we don't sell the leaves, nobody cares because, we sell the broccoli stalk? Or does it
Mhm.
just really not show any symptoms?
So the plant shows no symptoms, at least above ground, and I'm actually not sure
Hmm.
if you would see any kind of vasculature clogging in the broccoli if it's colonized. I expect that you wouldn't, because if you were seeing that type of vascular problems, you would probably see foliar symptoms as well. But yeah, there may be a Fusarium species that does affect broccoli, just not FOL specifically.
Hmm. Is there any concern to eating broccoli that would have fusarium in it?
So, no, not likely, especially if the plant isn't colonized, right? If you're not seeing the fungus
Hmm.
into the tissues that you'd be consuming. But definitely there are types of fusarium that can affect people. Typically, people with either compromised immune systems or like severe allergies to fungus. I think the disease is called fusariosis.
Hmm.
It's definitely not common, but it is something that does happen.
Super interesting. So, just kind of going back to the basics of the idea of wilt and that fusarium is colonizing the vascular tissue. So, is it basically clogging up the transpiration process? Like I think of plants wilting, right? Leaves wilting, and a lot of times that means that it's not, getting enough water, right? And so the leaves wilt. And transpiration is a big mechanism for propping the plant up, right? Having that turgor pressure in the leaves. So is that basically what's happening? Is that the fusarium is kind of creating this blockage to transpiration?
Yeah, that's exactly right. So it's clogging the xylem in the roots and it will work its way up that vascular system. Typically, if I were to cut open a leaf, I wouldn't see any type of discoloration or anything like that. It's really impeding the flow of water to the plant. So that is exactly why you see symptoms or the predominant symptom of wilting, and that's why it's called Fusarium wilt disease, right?
Can you actually see like the little mycelia network of like the fungal strands?
Yeah, the mycelium or the
Yeah,
hyphae.
hypha. That was the word I was looking for. Yep.
So typically, you won't see the hyphae when you're looking at the roots. Fusarium, when we're growing it we use potato dextrose agar in little petri dishes to maintain our isolates in the lab environment. And it's actually really a beautiful fungus. It's got these white, fluffy mycelium and then lots of purple in there. It's very cool to look at. But when you're looking at root cores, it's really just what you're seeing is rotten brown or reddish brown tissue of the plant.
Not so pretty on the plant, but pretty in and of itself. Um, do so okay, Fusarium likes to live in soil. Does it spread by the air? Can it be airborne?
Um, the spores could be airborne, right, of the fungus, but I think that that would be really atypical
Okay.
as a mechanism of spreading. Really, it's through either seeds that were infected by the soil or infected soil. That's really what it comes down to.
Do growers sanitize or clean their seeds before they plant them?
I don't think that that's a typical procedure. I suppose just out of concern for destroying your seeds or killing them, right?
Sure.
It's not like you can autoclave them. You may be able to treat them with a bleach solution, but I'm not sure. And I don't think that any of that is a common practice. I think it's normally like buy them and plant them, you
Yeah,
know.
it seems pretty intensive to have to clean those seeds
Mhm.
before planting them. So, do greenhouse growers and vertical farmers need to be concerned about Fusarium if they're not growing in soil?
So, even though Fusarium is mostly categorized as a soil-borne pathogen, it can actually also be waterborne. When we inoculate our plants for these trials, we're doing that with a spore suspension, which is just spores mixed into water. So this pathogen certainly can infect hydroponic systems. I was actually just looking at a case study in Canada from 2018 where they found Fusarium and Pythium to be the causal agents of plant disease in a hydroponic cannabis system.
Ooh.
And they were also able to detect this pathogen in the recirculating nutrient solution. So it can absolutely be an issue in hydroponics if you were to have some sort of exposure to this pathogen.
So maybe what some growers think is Pythium could actually be Fusarium, or maybe a combination of both.
Yeah, yeah, certainly.
And we would think then that that would be probably coming from the seed or from maybe an irrigation, a recirculating irrigation system that wasn't properly clean. Like where would the Fusarium originate from?
Yeah, I certainly think that the seed is a possible explanation. I do think that once that mechanism of transmission was identified, growers and breeders have been doing a much better job of preventing their seeds from becoming infected. One of the other really common ways is if you're using soil as your growing medium for
Yeah,
sprouting your
yeah.
seedlings, which I do know some growers do that. So you need to make sure that your soil is either coming from somewhere where you can know reliably it was not collected from fields in Arizona or California or Florida. Now, Florida also has this pathogen, or that your soil has been sterilized in some way. And then also through, people tracking it in on their shoes. If you have a greenhouse
Oh.
in Arizona or California and one of your employees was walking around near some lettuce fields, they could certainly bring it into your system if you're not either switching shoes or stepping in a bleach solution or other sanitation products.
People are always the vectors, aren't we?
Mhm. Yeah, absolutely.
Well, I know also with cannabis, there's a lot of growers who like growing in, quote unquote, living soil, because they like having that microbiome. They have multiple plants growing, in large beds of soil. I know that the quality of soil and consistency of that, or the soil origin can be of concern. And so I don't know, just my expectation would be that, maybe soil grown cannabis could be potentially more susceptible to fusarium issues than even hydroponic counterparts.
Yeah, yeah, or even to any other type of plant disease or fungal pathogen. Really, when you're working with untreated soil, there's a lot of unknowns there.
Yeah, yeah. So what is next for fusarium wilt research? If you were going to continue your research, what would you be studying? What would you want to study?
So right now in our lab, like I said, we're doing those salinity trials to see if there's either the saline soil may confer some resistance to the pathogen, or the pathogen may confer some resistance to saline toxicity. But what I really wish, I was thinking, oh, I could stay for a PhD, would be to look at the lineages of either the
Hmm.
varieties that I've identified or the varieties that other researchers have identified to try to find the traits that confer this resistance. Because really, number one for combating this pathogen is prevention, preventing it from spreading anywhere else. But right behind that is selecting and breeding resistant lettuce cultivars.
Yeah, because I'm assuming there's nothing you can do once the plant has exhibited symptoms. Is that true?
Yeah, there's no treatment available for this pathogen. Really, it's all about prevention.
Interesting. And I'm assuming you've communicated some of this to the seed companies that you got your seeds from. What has been sort of their response to this research?
So we actually have not done that yet.
Okay.
That's good. Yeah, but
Surprise.
we will. I know we will before we publish this research, I think.
Okay.
And there are a couple companies. Well, I guess there are maybe three or four of the varieties that we tested. The companies had them labeled as resistant to FOL.
And they were?
So yes, yeah, and they
That's
were.
good. Okay.
But there are a couple where either they never tested that or they just didn't publish that information. So I some of them it will be good news to them, I think. And really when we were doing this experiment, we ranked the lettuce as either highly susceptible, susceptible, partially resistant, or resistant. So there's kind of a spectrum of resistance, and I think that this information will be valuable to the seed companies and their breeding programs.
What is the economic impact or what has been the economic impact of Fusarium wilt on the lettuce industry? I mean, are lettuce growers losing 10% of their crop, 50% of their crop? Are there losses in the millions, billions of dollars annually? Do you have a sense for that?
So, lettuce production in Arizona and California is evaluated to be worth about $10 billion. Unfortunately, the
Combined.
FDA, yes, yeah,
Okay.
combined, and
Okay.
Arizona is only 1 billion of that, but
Oh,
uh,
okay. I kind of thought it
it's
would be
yeah,
50-50,
I
honestly.
know. No, California's definitely got us beat, but we're trying. But
Yeah.
the USDA actually has not published any information specific to crop losses due to Fusarium, right? They do
Really?
publish other pathogens, other fungus, but nothing for Fusarium yet. And that was actually a question at my defense that I had searched high and low for even just news articles about oh, this farmer in Yuma had devastating crop losses, but there was nothing. I did find some papers that cited up to 70% crop losses in lettuce intensive cropping systems. And yeah, if you pick the wrong cultivar, that's totally within the realm of possibility. But like when we were
Wow.
discussing how there's multiple strains present in any single field, you may see in half your field all your crops are dead, but in this section they're fine because there's just a slightly different strain in the two different areas, even just 100 feet apart.
And that other strain could be just out competing the bad strain and keeping it at
Hmm.
bay.
Yeah.
Has anyone tried inoculating with the benefit or the non-destructive Fusarium species to try to outcompete the bad Fusarium?
Not that I've seen in my like review of the literature, but that may be possible. And if not, it's certainly an interesting option for future research or even looking at other fungal pathogens to see if there's something that could outcompete the
Sure.
Fusarium.
Maybe we infect, maybe we that I shouldn't say that. Inoculate those fields with Eutypa. And see how that goes. Combat Fusarium for lettuce with
Mhm.
Eutypa and combat Eutypa and grapevines with Fusarium. I mean, why not?
Yep, there you go.
They seem
We
to be natural enemies.
just keep adding more diseases to the soil.
Why not? I mean, are there certain soils that are more susceptible to having fusarium growth?
Not that I am aware of. That certainly might be possible, but really, the in Tucson and I guess in Yuma, we have loamy soil, right?
Mm-hmm.
But that's very different than the coastal soils of California and soils in Japan. FOL has also spread to South America, Europe. The first example of Fusarium in Africa was found in Egypt, I think in maybe as recent as 2010 or 2008 or something. So
Hmm.
it's certainly still spreading, but I think all of those regions have very different soil makeup. So I don't think that it's too selective, or if it is, then it will just adapt to the new environment.
So is the fusarium just lying dormant, waiting for some lettuce roots to colonize, or is it living on something else in the soil until that lettuce is planted?
So it can lie dormant for certain periods. And like we discussed with the broccoli, it is looking for other things to colonize. Really, if you had a infested field and you were to just never plant anything in it for, I actually don't know how long it would take, you would see a dramatic decrease in the fungal population in there. And that's why the crop rotation helps. It's not a perfect solution, but it certainly does need some type of host to really maintain the population.
When you say crop rotation helps the fungus, not helps
No, it
take the
helps.
fungus out.
It does help take the fungus out because if you're planting a crop that it cannot colonize, it's going to lessen the amount of the fungus in there.
So what does it not colonize?
I actually don't know.
Oh, yes, we stumped her. Corn?
It does infect cereal crops, but I'm not sure about corn.
Hmm.
Hmm. No, I don't know. I'm
All right,
sorry.
we're gonna have to get back to that one. Yeah, I'm just thinking like if crop rotation can help, like what would be the right crop to rotate through there when you're not growing lettuce or any other of those susceptible crops like a cereal crop.
Mm.
Hmm. More research, right? More research to come.
Yes. Yeah, absolutely.
So what's next for you, Emma?
So I'll be here in Arizona for just a couple more weeks. Really sad to leave, but trying to get some camping and, see those mountains a little bit more before I move back to the East Coast. So I'll be moving to Chicago for a couple months to train for my new apprentice grower position, and then I'll be
Okay.
moving down to Georgia. And so I'm
Georgia.
yeah, I'm very excited for this position. It's really exactly what I was hoping to, the exact type of work I was hoping to do upon graduation. So super excited to continue working with lettuce and produce food that people can find in their grocery stores.
And maybe deal with other pathogens.
Yeah, certainly
Yeah.
pests, pathogens, all that. So
Yeah.
very
Yeah.
exciting.
Well, congratulations. And it's going to be such a change of environment from somewhere hot and dry to somewhere hot and humid. I wish you
Yep,
luck.
yeah.
But you're from
Thank
Virginia,
you.
right?
Yes, that's correct. So
Okay,
pretty used to it, but the deep south is different, I think.
for sure, in a lot of different ways. Um, so the last question I always like to ask my guests is this one, which is what do plants crave?
I should have prepped this one.
Or what does lettuce crave?
What does lettuce crave? What do plants crave? I should have prepped this one because I've listened to like so many of your podcast episodes. I should have thought about it. Oh my gosh.
Well, I mean, what would your lettuce plants crave? The ones that you did research on.
Water.
Water.
No. Right. An epiphany. So, what I think plants crave, aside from all the typical things that we know they need, nutrients, water, sunlight, adequate temperature and humidity, I think something that's also essential is oversight of the plants, making sure that you're identifying any types of problems early. those sorts of
Mm.
things can really be essential to producing good crops, you know.
So some love and attention.
Yeah, exactly. Love and attention is what they need.
Nice, nice. So what I was thinking, just based off of some of the studies you're planning to do is raising the salinity levels to potentially create some resistance, uh is salt. And why I asked if you'd seen Idiocracy is it has a very agriculture bent to it. And they propose watering these plants with Brondo because Brondo has electrolytes. It's basically Gatorade. And so they're like, it's what plants crave, electrolytes. And nobody knows why. But it's
Mm,
basically salt. So anyway, that's why it's your homework. Go watch that tonight.
okay.
And yeah, you'll love it. You save the world with agriculture. Of course we do, right?
Yeah, exactly. It's important, you know, you gotta love your farmers.
Exactly, exactly. All right, so I'm going to wrap up with my rapid fire question. So these are just meant to be quick responses. If you want to expand on anything, please do. All right, you ready? Okay. Are plants introverts or extroverts?
Extroverts. Well, maybe it depends. Um, Vining crops are definitely extroverts
Why?
because they have, you know, their little vines and they're reaching out trying to grab everything.
Okay. What about your lettuce plants?
I would say they're also extroverts. The morphology of lettuce is very open. I guess maybe the crisp heads, as they get older, they become a little more introverted.
Okay, I like that. What is one piece of advice you'd give to growers to prevent Fusarium wilt?
If you want to find out if there's Fusarium in your soil, plant a known susceptible lettuce cultivar. If you want to prevent infection, whether you know it's there or not, select a resistant cultivar.
Nice. What have you learned from plants?
I have learned so much from plants and from working in the greenhouses. Um, I think that your conditions are important, you know, and that's for humans and plants,
Mm,
right? You want to make sure that you're in a healthy environment as well. Um, I've also learned that there's a lot that you can control, but there's also a lot that you can't.
what advice do you have to future grad students or people considering grad school?
I would say follow your passions. If you're working in some sort of field and something else grabs your interest, don't be afraid to move on and follow those threads that you really find stir something within you.
Love that. Love that. Describe your favorite salad, especially what type of lettuce is in that salad bowl.
Okay, so I really like this is one's kind of weird, but
Perfect.
it's a warm bacon dressing salad.
Mm,
So you'll use for the dressing, it's vinegar, a little bit of bacon grease, you know, different spices, whatever you want to put in there, olive oil. You emulsify all that, and then I really like arugula, and then a little bit of iceberg in there for some crunch, bacon, chickpeas, onions. Yeah, that sounds pretty good.
that does. I love chickpeas in a salad. I'm so glad you said that.
Hmm.
Yeah. Well, if anyone needs the recipe to that dressing, you can contact Emma or contact us. We'll put
Yeah,
you in
yeah.
touch. Um, well, Emma, thank you so much for talking about the research you did. It sounds like, very critical research to be able to continue the lettuce industry, not just in California and Arizona, but everywhere around the world. And at least for the time being, it seems like, greenhouses and vertical farms are going to be less susceptible to Fusarium. There might be other things that those lettuce crops are more susceptible to. But in the meantime, it seems like maybe this is a strategy to avoid, or hydroponics is potentially a strategy to avoid this particular disease.
Yeah, absolutely. I'm a huge advocate of CEA and hydroponics. So definitely, as long as you don't have any contamination coming in, it should be fine.
Awesome. Well, thank you so much, Emma. Good luck with your move, and have fun training at Bright Farms and working at Bright Farms. And I hope I get to visit you one day in Georgia, growing lettuce in a greenhouse.
Yeah, absolutely. We'd love to have you. And thank you so much for having me on your podcast. This has been really great.
Awesome.